Let us discuss the first type of bonding called as ionic or electrovalent bonding, which simply involves the transfer of electrons from one atom to the other. Here we draw an analogy where we consider a case there are two people A and B. A has 100 rupees, B has 100 rupees. They want to buy a burger. So A gives his 100 rupees to B, and when he gives his 100 rupees to B, B has now got 200 rupees and he can go and buy the burger. In the event, A becomes a donor and B becomes an acceptor. A becomes short of money, whereas B has the extra amount with him. Similar scenario is seen in the case of atoms, where atom having 1, 2 or 3 electrons in its valence shell is capable of donating these electrons to another atom which may be short of it, which in turn needs 1, 2 or 3 electrons depending upon how many valence electrons it already has. So if it has 5 electrons in the valence shell, it will need 3 more electrons. If it has 6 electrons in its valence shell, in order to complete the octet, in order to have 8 electrons in its valence shell, it needs 2 more. If it has 7 electrons in its outermost shell, it needs only 1 electron to complete its octet. The atom which donates electrons will now have an extra positive charge. In other words, it is short of electrons. So it becomes an electropositive ion or cation, an ion with a cut. On the other hand, the atom which gains electrons forms what we call as the electronegative ion or the anion. That means the one with the negative charge over here. Because now these atoms turn into ions which are oppositely charged, we know that opposite charges in nature always attract each other. And this is what holds the two atoms close to each other and resulting in the formation of what we call as the ionic bond or the electrovalent bond. Electrons of the valence shell being involved in bonding, or a type of bonding which is resulting in the formation of ions is why we call it as ionic bond. Here, the atom which donates electrons is usually a metal atom. So this is an easy way for you to make out whether a particular atom would be metal or non-metal. If it has 1, 2 or 3 electrons in its valence shell, it may be an atom. If it has 5, 6 or 7 electrons in its valence shell, it may be a non-metal. I've taken a very simple example of electrovalent bonding and have represented by what we call as the Lewis structure or the dot diagram. This particular representation involves only representing the electrons of the valence shell, that is the outermost shell. First, we take the case of magnesium with an atomic number of 12. Its electronic configuration is 2, 8, 2. In other words, if it loses these 2 electrons, now the valence shell will become the second one and it will have 8 electrons in the outermost shell. Now, a thought that arises in our mind is, why not take up 6 electrons? Now, taking up 6 electrons means taking up a lot of load. It needs positive charge in order to handle that many electrons, which it does not have because it has only 12 protons in its nucleus. If you remember, atomic number is the number of protons or the number of electrons in an atom. So if it has 12 electrons, it has 12 protons. If it now acquires 6 more electrons, it will have 18 electrons in all and only 12 protons to balance it, which it will not be able to. Hence, the possibility of acquiring 6 electrons does not arise. It comes across another atom which is only short of 2 electrons if it wants to have an octet. So, oxygen has 6 electrons in its valence shell. If it gets 2 more, it has a complete octet. When we represent the Lewis structure, we have magnesium with 2 dots, oxygen with 6 crosses. Now, the dots and crosses do not mean that the electrons of the 2 atoms are different. These are represented differently just to make the concept more clearer to the student and to the person who is studying it. Now, magnesium has 2 electrons extra. Oxygen is short of 2 electrons. Oxygen says, please lend me 2 electrons, and that's what magnesium is happy to do. It transfers 2 of its electrons to oxygen. Now, in the process, it had 12 protons in it and 12 electrons. After it transfers 2 electrons to oxygen, it still has the 12 protons, but it is short by 2 electrons now. So this particular Mg ion has 12 protons, but only 10 electrons. In other words, it is short of 2 negative charges, or the other words we say is that it has an excess of 2 positive charges, and that is what we represent as a superscript over magnesium. This too indicates the number of electrons given away, and positive charge because it has an excess of protons now. Consider oxygen. Now, it had 6 electrons. It acquires 2 from magnesium. In the event, it had 8 protons initially and 8 electrons. Now, it has 8 protons but 10 electrons. That means it has an excess of negative charge. And how many negative charges are extra? 2. Hence we put a square bracket just to avoid confusion, and we have O with 8 electrons. These 2 dots here indicate that the electrons have been acquired from magnesium. Remember, these electrons are in no way different from the electrons of oxygen atom. It is just for clarity. You may put crosses also, and this becomes 2 negative. This is how we have magnesium oxide. That is why, if you notice, when we write the formula of magnesium oxide, we say MgO. The number of electrons transferred by magnesium in order to form a bond becomes its valency. So here the valency of magnesium is 2, and the valency of oxygen is again 2. But magnesium has a tendency to lose, hence it forms what we call as electropositive ion, whereas atom B, that is oxygen, has a tendency to gain, that is why electronegative ion. Looking at the formation of the bond, there's something interesting that we can decipher about its nature, because that is what we said in the first video. We said the type of friendships a person makes decides his character. So, magnesium oxide is formed, the 2 of them have formed a friendship, they have formed a bond. This bond is formed by the attraction of 2 opposite charges in nature. This type of an attraction is very strong, and because it is very strong, it is held closely. That is why we find that compounds which are formed by ionic bond are strong compounds. In order to put these ions away, in order to melt them also, you will need high temperature. Usually you will find them in solid state, because each positive ion will attract a number of negative ions around it. Same way, each negative ion will have an attraction for a number of positive ions around it. That is what holds it in place. That is what holds the ions in place. Hence, they will have a definite structure or geometric shape as well. When we come to their solubility, we will find that these can only dissolve in polar compounds like water. What are polar compounds? We shall discuss in further lessons. This will dissolve easily in water but not in non-polar compounds. If you talk about their conductivity, we notice that as a solid, because the ions are surrounded by oppositely charged ions, what will happen is they will not be able to move easily. Hence, these compounds will not conduct electricity in the solid state. On the other hand, if we melt them, melt means the forces of attraction between them are weakened, or we dissolve it in water. In the same way, the ions will get separated, and that is when they will start conducting electricity. Hence, they are very good electrolytes, that means substances which will conduct electricity in molten state or aqueous solution form. Same way, because their bonds can be easily broken by water, they will dissolve at a fast rate in polar compounds, for example, water. Hence, we see that once you understand how and why a bond is formed, you are able to decipher a lot of properties of that particular compound and are able to predict its behavior in different cases. Our next video will cover the covalent bond formation.